Welcome to a new test and teardown video. This time it's a Radiometer RLC component comparator type TRB11. It is from about 1970, and of course back then you didn't have super accurate meters to measure inductors, capacitors, or something like that for your production line. So what this instrument is doing is it sends out a 1 kilohertz signal into a bridge. You can see here it says this is the unknown, and here's a 1 kilohertz. So the other part of the bridge is the reference part. So the idea is you have some known good components in your storage, and then you just put them in here, and then you compare in your production line the new parts to the known good one, and then you can measure the percentage deviation from that. And of course it has the different modes for that readout in the values. And there is an upgrade or some external, it looks like a remote control, but it's just an indicator box you can have external. I will put in a picture here. It is from peel.dk. So this remote box got 3 lamps on the top. Says yellow and green and red, where you can see if it's too low or too high or if it's accurate. And there's a little trimmer where you can set the trip point, because if you don't have this one, you cannot set anybody or ask anybody to do this without some sort of qualification or something like that, because then they will know, is it a little bit too high or is it a little bit too low? So it's a matter of evaluation. I mean, it's easier just to have a lamp that goes red or green, I think. Then there is no argument. And here is the name label. It says the TRB11A, and that is the serial number. The backside here is full of some interesting stickers. It looks like here they bought this unit, and this was the number 3 unit, and this is the purchase date. I mean, this is the lowest number I can find. I cannot read this. We got 2 labels on top here, and then it says control in 72. It's repaired in 84. Something else happened in 73. Another control. It's repair by Radiometer in 87. So they used this one for quite a lot of years, and now I got it, so I can play with this one. Here is the external box connected. And look at that. This is a circuit board with the text. And everything here looks a little bit quite modern compared to a lot of other Radiometer products. There's another thing that bothers me a little bit, and that is this. Okay, there's a little bit of lubrication problem here. I'll try to figure out how to open this, but I think we can unscrew this and then flip down the front. It is a little bit full of dust and dirt. Oh, but look at that, how beautiful that is made. This is the balance potentiometer, where you set the zero, the perfect zero between the reference and your tested in this bridge setup. And look how it's shielded like that. So beautiful. Yeah, I can't wait to open it a little bit more. It is just so beautiful the way this is constructed. the way wires and the harness here is just done with shielded cables and tied up, mounted real stable. I kind of like it. Now I can much easier access this dodgy switch here and give it a little bit of cleaner. Oh yes, of course they're using a good grounded cable, so all that is fine. Germanium transistors for the power supply. Ooh, what is that? Oh, gotta open here. I think this is the way to flip it open and to access everything. All the wires, those cable holders here, they can just be flipped open, and then you can pull out all the cables like that, and then you can access the board from both sides. And we got actually a little hinge down there, so it's a very, very intelligent design. And oh, look at that part right there. This little glass part in the middle of the picture with the black, red and white little paint on it, that is one of those thermistors for the oscillator. And there's a 1 kilohertz sine wave oscillator here, and then there's this transformer that is a part of the test bridge. And the rest is of course just amplifiers and meters and all that kind of stuff. I don't find any leaked capacitors or any brown parts. I do see some rusty. Look at that test point, how rusted that is. So of course this was maybe left in somebody's basement or something. Oh, this is the main transformer, by the way. And that yellow part here is the bridge rectifier. And that is the power supply. And here is a little shielded part. I think, yes, this goes to the two bridge end cables. So this is the other part of that bridge. So, yeah, it's just shielded on both sides. Let's open and have a look in the most holy place in this one. So that will be the sample and the reference. And they go into a little, see, capacitor resistor system. And there's a field effect transistor and some normal transistors and all that, amplifying and whatnot. Beautiful, this design. And also look at this shielded box. We also got a shield on the other side. And here, of course, this top side. And even back in 1970, when they made this one, even back then, they knew to have all the signals in and out of a shield box at the same end. Or the smaller this point is, the better this shielding and the better everything really works. So that is the fantastic thing. And this is some sort of a forgotten style, because today a lot of people forgot all about this and just have wires going all the way around, and then it's not working. So it's very interesting. Let's look a little bit at the circuit board layout. It is very, very obvious this is done with tape on film, way before we had CAD. And look at some of the cool details about this layout. This track here goes all that way, and it's because they had an idea there were going to be some other connections here, right? But why would you do that? And it's all these, and it's just, instead of going it like that, and the way that tracks just follow other tracks, and the way, I mean, it is just beautiful. But It's just fantastic. I design circuit boards for a living, so it is. I really, really enjoy looking at the old ways of doing things without CAD. And there's a nice way to handle the mains input voltage selector. Well, you just solder the entry point, and they marked it nice and clear here on the circuit board, so I kind of like that. Because I haven't got the schematic for this one yet. When I get the schematic, I will of course put it on pl.dk via my friends that own this site. But we are working on that, so that is a thing that will happen. So here is what I've done. We are now in resistor. I put in a 1K resistor here at the unknown and a 1K resistor up at the known. There is a between 0.5% between the two values, and we are in 6% full. 1.5 is the full range, so it should have been like that, 0.5%, but it shows a little bit less. There's of course this little calibrate thing here. I think you need to put on something that is exactly the same, 0.0 something, and then of course you hit this one and then you dial it or something like that, right? So let's try and do something a little bit more radical. If we take this away, my 1K, what if I take 1K1? That is 10% away, isn't it? So let's see what happens. So this is this 25% full range? No, it's reading way too little. So this is 6% full range. There is, it says 2%. So, yeah, it's reading way too little. Why is it doing this to me? Yeah, there's full of... Anyway, but I think you get the point. Seems like it is. I would expect it to hammer all the way out. Okay, it is doing that. Good. Maybe I'm doing something wrong. I don't understand this. I think the reason why I don't understand it is that it's not working. Well, when I get the schematics, I will definitely be able to figure out exactly what is going on, because 10% here is not at all in any way what it is supposed to be. So I think I will end this video right now, because there's not a lot more to do today. So thank you very much for watching. See you around. Bye bye.